All right, guys. Oh, this is going to be fun. Oh, hey, Martha's going to be joining us today. Martha, hey, wait, where did you go? Martha, come back. Martha, sweetie, it's right there. Hi. There she is. Okay, Martha's going to be, Martha, pull. No, we're here. Martha, pull the door. Pull. Martha. Okay, guys, I'm sorry. I have to go let Martha in. Hold on just a second. I'll be right there. No, wait, Martha, no, don't leave. Okay, hold on. Wait. Martha. Okay. We got her. She's seated. Glad you could join us. How's everybody doing today?
Great.
Woohoo! Yay, Alaska. You guys here with us today? Wonderful. Tennessee? Wonderful. How many people we got today? 1, 2, 3, 4, 5, 6, 7, 42 million again. How about that? That's pretty cool. Anyway, today what we're going to talk about is perception. And I wanted to start off with just a little bit of story. Martha, I'm sorry that you had a little bit of difficulty there. I know that you were having a hard time perceiving where the door was. I know exactly what that's like, guys. Check this out. Back when I was in my early 20s, I got on a plane. And I had never been on a jet plane, and I'd never been on a plane before. And we walked up to my seat, and the seat was right outside where the wing was. And I looked out the window, and I saw the wing. But my brain had never experienced that before, and it looked funny to me. And so my brain, I specifically remember this, my brain actually saw the wing as a large tract of farmland that was like maybe 400 yards away. And I looked at it, and I looked at it again, just like Martha was doing with the door. She's like, I can't see it, I can't see it. I was looking at the wing, and I finally turned to my friend and said, look at that weird farmland down there. He's like, it's the wing, Ben. I was like, perception. It's the ability of our senses to detect the stuff that's all around us. So like when we use our fingers, what's that perception called, guys? Touching, exactly right. What's this one? Hearing. Yeah, exactly right. So the one that I want to start with today is with our eyes. And we're going to use a star field to play a little science experiment with. Check this out, guys. I've got a star field that some of you have probably seen before. It's really cool. If anybody have used computers before from back in the 90s, they will recognize this star field because this was a part of, like, was it Windows 98? Some of you probably weren't even born yet, but there it is, right there. Now, this experiment involves, wow, we've just achieved warp 7. For this experiment, we need that video, a piece of 8x11 paper, and what's he doing in there? Thank you, goodbye. A bowl and a pencil. Thanks, science hand. So you're gonna take your paper, you're gonna fold it hamburger style, like that. You're gonna put the bowl halfway on the fold. In fact, let me move these papers underneath it so you can see that a little bit better. You see how the bowl's halfway on it? Take the pencil and draw a half circle. Now, oh dang, I forgot scissors. Science hand, I need some scissors. Could you give me some scissors, please? Those are your scissors, I need my scissors. Those are Martha's. Yeah, we have them here. There we go, there's my scissors, all right? So, as you can see that we've created a half circle in here, and I'm going to cut it out. Does it have to be exactly perfect? No, not at all. Does it have to be close to perfect? Yes. No, it doesn't. No, just cut on the lines. If you go over the lines, it's not that big a deal. Because what we want to create is a circle in your paper, like that. Oop, I just ripped it. Does it matter if I ripped it? No, it doesn't. Now, I'm going to take this over here to the star field, and I want you to notice something. Your perception of the stars is probably going to change. So right now, we can see them. They all look like they're moving. If I hold the paper up, I want you to look at the stars right in the middle. Does it look like they're going slower or faster? Can you even see that? Kind of hard to see that from where you're at, huh? I'll tell you right now, the effect is that they're going slower. Now, I'm going to hold it back up here. I'm going to cover this. Now look at the stars going around the outside. Are they going slower or faster? Still kind of hard to tell, isn't it? Okay, no worries. We take the paper. This works really well if you have a small screen. That's not a small screen, that's a very big screen. This is something that everybody can do right now. You guys in the audience and everybody at home, you can do this right now. Make your own circle with your hands, like this. See how we have an opening right here? An aperture is what we call it. Hold it right up to your eyes like a spyglass. Turn around and we're gonna look at the screen. Well, let's put the screen on full so everybody can see it at home. Hold your hands up so that you're only staring at the center of the screen. Now, what speed are the stars going? Can you tell? Does it look like they're going slower? Because it should. Now, with that done, take your hands down and just hold up one hand, put your fingers together, and I want you to cover the entire middle of the screen. And just so it's the edge of the screen is showing. What speed are the stars going now? Can you see how they went faster? They are. That's really cool. Now you guys here in the audience might be too far away and we'll have you do that at home. You guys at home, you can do this very easily. Just go onto YouTube and type in Starfield simulation. Thank you very much. And hold your hand up and do that right to that screen and you'll see how the stars will go slower and faster. Are they actually going slower and faster? No, they're not. But your perception of it changes. And the reason it changes is because of context. Context is kind of a big word. Does anybody know what context means? Oh, what does it mean?
Context basically means
The meaning of something. Good, very good. Context is everything around you, all the cues around you that help you make sense of something. Kind of like when I looked at the wing on the window, I didn't have anything to make sense of it all because I'd never looked out the window before to see it. It's really fun. Go try it at home, guys. It's science. Science, yeah, that.
Spark Science.
Okay, I got that one. I got that one. Ugh. Okay. The next experiment I have for you, this is a quickie and dirty one. And this is really kind of cool because when we were practicing this today, before we went on, it didn't work the first time. This experiment literally didn't work until I changed one thing. I changed the context of one thing. So everybody here in the audience, I want you to stand up and stay 6 feet apart, but scoot back as far as you can and just stay spaced out. Okay, everybody go, do that. At home, you can just stay right where you're at. It's just fine. This one is called the Hermann illusion. It was named after Ingmar Hermann, who first created it in 1870. This illusion is called a vanishing illusion, and you're going to see why here really quick. It involves a grid pattern, and we're going to put the grid up on the screen for you to see it. The grid that you're going to see is actually a new and updated version of the Hermann illusion. Here it is right here. The original illusion was just a bunch of white lines surrounding black squares, and as you can see, this one is a little bit different. Now, guys, here in the audience, I want you to tell me, I want you to shout out loud, I want you to stare at this circle right here. Guys at home, I want you to stare at the circle, the black circle right in the center of your screen. I want you to tell me how many little black dots can you see? Go ahead and shout it out. Alaska, how many can you see? You can see 3. How many can you guys see?
5.
You can see 5. That's really good. How many at home can you guys see? Oh, louder? Oh, no, that's right. You're at home. I can't hear you. There are actually 12 dots on this whole grid. Take a second and count them. One by one, you will see that they're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But because of how our brains work, we don't have the ability to see all of these dots at the same time. Now here's where it gets really interesting. It doesn't matter what dot you look at. Take a second, look at the screen again, and look at the corner dot up in the top right corner. How many black dots can you see now? How many dots can you guys see? If you look at the top one, how many can you see? You can see 4 looking at the top. Good. How many can you see? Just 1? Yeah, exactly. The really cool thing about this experiment, guys, is scientists still don't exactly have a handle on why we lose vision with those dots. We've got a bunch of theories out there, a couple of ideas, but actually we don't even know why. So maybe one of you will grow up and become a doctor who figures this out. That would be cool. And that is science.
Spark Science.
Oh! Wow. So, just watching a little cowboy movie in the middle of this, but the movie was in 3D, and you notice that I have my 3D glasses on. Now, these aren't really technically advanced. It's just a piece of red film and a piece of blue film, one over the right eye and one over the left eye. But when you couple this with a movie that has the red colors and the blue colors divided on screen, it creates the three-dimensional image. Now, what I wanted to show you for this next experiment has to do with colors, and specifically the primary colors. Do you guys know what the primary colors are? Anyone? Afghanistan? Yeah, say it out loud. Oh, that's right. You're in Afghanistan. You can't hear. We can't hear you. Guys, what are our primary colors? Red, yellow, and blue. Good. If you're a television, your primary colors are red, green, and blue. So we're going to walk back here to the other science corner where I have the primary colors on a television set. Now I'm going to move my Tesla coil. Don't worry, we're going to play with him again later. But I want you to focus on something really interesting. I told you that perception is about context and about how we see things. Watch what happens on the back. Wait a second. Science hand. Could you give me a white screen, like a little bit bigger than this paper? Go see if you can find one real quick. This is going to be worth it. If you don't have this at home, don't worry about it because we're going to make it very easy for you to do this at home too. Thank you, Science Hand. All right, guys. I need you to tell me what I'm going to point to. I want you to tell me what color you see. Red. Blue. Green. Now, because of how our brain works, we can see a myriad of colors. That has to do with our brains and our eyes. Watch what colors appear on this white screen. Can we get that? Can you guys see those different colors right there? William, could you come up here for just a moment? Because I need you to point to the secondary colors that have appeared. Can you point to the magenta? There it is. There's magenta. Point to the cyan. Good. And point to the yellow. Right there. Now, if you guys are having a hard, thank you very much. And let's give William a hand. Thank you very much. If you guys are having a hard time seeing that, don't worry. We're going to make it very easy for everybody at home too. And the way we're going to do this is pulling up a 4-color, science hand. I'm done with that. Can you put that away, please? Thank you very much. We're going to pull up a 4-color grid right now that has red, green, blue, and yellow. Now, what I want you to pay attention to is grid 1 right here. This is the first color that I want you to memorize. Right here is grid 2, here is number 3, and here is number 4. So everybody, in your biggest outside voice, tell me what color is in grid 1.
Yellow.
Yellow. Grid 2?
Blue.
Blue. Grid 3?
Green.
Green and?
Red.
Red. yellow, blue, green, and red. Now's where we're gonna freak it out and make it tricky. When your eyes stare at something too long, they tend to get tired and they stop seeing that color. The perception of your eyes changes. And not only does it change, guys, it changes 180 degrees. You remember our cat video that we had a while ago where the cat was just spinning around from side to side? No, not that cat video. The cat video, that one. Remember how we used this in episode 1 with spinning things, but we learned that the cat was only going back and forth and he wasn't spinning? Your eyes are doing essentially this trick right now. They're going to see 180 degrees the other way, the opposite color. You ready to try this? Okay, what I want you to do, everybody, is stare at the middle of the screen right now while I count to 30. Don't blink, just stare at it. When I reach 30, I'm gonna say go. Your job is to then look at a white screen. Now, for those of you guys at home, we're gonna put up a white screen for you to stare at. What I want you to pay attention to in that moment is what color are in 1, 2, 3, and 4 quadrants. You ready? Because I'll tell you right now, it's gonna be different and really cool. Here we go. Stare now. 1, 2, 3, 4, 5. Don't blink. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We got 10 to go. 21, 22, 23, 24, 25, 26, 27, 28, 29. You ready? 30. Look at the white screen. Whoa is right. You don't see yellow, red, green, blue anymore, do you? What colors do you see? Yeah. Purple, a pink, an orange, cyan, exactly. You're seeing the same colors that we had over here on the wall with the addition of 1 because we added yellow to it. That's because your eyes got tired and its perception changed. It's science.
Wait, what?
Spark Science.
I've got another experiment for you. This one is absolutely my favorite. Oh! That's right, it's time for Science Corner. Aha! Science Hand. Hi, how are you today? Oh, you're looking great. Hey, who's our science guest today? Oh, that's right. Guess what, guys? Science Hand is our special guest today. Science Hand is going to share with us his favorite science website, which means if you're at home and you're sitting at a computer or you've got a phone or a smart device, you can type in this address and follow along with us. Okay, Science Hand, show it to us. We're ready. Are we ready, guys?
Yes.
Oh, yeah, we're ready. Okay. Oh, thank you very much. Yes, we're going to need a mouse because we're going to do some survey. Oh, yes, we need a keyboard, but we can't. There's just. Oh, wait, Science, I got it. Do you remember that lap desk that you got for Christmas? Yeah, let's use that. This is really cool. Science Hand got a lap desk for his computer for Christmas. Look at this. Isn't that cool? You can just put the keyboard on it like this, the mouse on it like this, and here we go. Okay, Science Hand, type in the address of your favorite website. Here we go. No! I don't think that was it. Yeah, you're just being funny, weren't you? Okay, do it real this time. Okay. Yep. Okay, cool. Oh, Science Hand, that's your family vacation video. Your favorite website, please. Everyone's waiting. Oh, there it is. Science Hand, tell everybody what the address is for this website. It's earth.nullschool.net. Did I get that right? Earth.nullschool.net. Don't worry, we'll post it up on the Facebook page and all those places so you can see it. This is really cool. Okay, Science Hand, show us what you can do. Grab the mouse and let's start. Oh, look at that. So this, of course, is the Earth, and we can see all corners of it, which is kind of a funny thing to say because the Earth is a globe and doesn't have any corners, but we can see all the way around it. Now what you're looking at right now with this are wind currents, the actual wind that's flowing over planet Earth right now. But these are just the surface winds, like the winds that you would go outside and feel right now. So let's change it just a little bit, guys. Watch this. Yeah, go down here to the corner, show a science hand. You're gonna click on Earth, and we're gonna go to the part that says height, and we're gonna go all the way to the end where it says 10 HP. That stands for hectopascals. That's just a very fancy word of saying that we're gonna go up really, really, really high in the atmosphere and look at the winds. And when we click on it, we see the winds that are blowing around way high up in the air. These are even higher than the jet stream. Now, you see how they're different colors? Isn't that cool? Science hand, go click on the purple. Let's see what the purple will tell us. So these are the winds over, where is that? Antarctica right now? Good. If we look down in the corner, I don't know if you guys in the audience can see it or if you guys at home can see it, but if you look down in the corner, it says that the winds right there where we dropped the mouse are 185 kilometers per hour. Now we're in America, we don't use kilometers an hour, so we're gonna click on that and change it. We're gonna change our perception of it again. So that one was meters, keep going, clicking, there it is. That one says that the winds right there over Antarctica, way up there, are 115 miles an hour. Science hand, do you think you could stand up at 115 mile an hour winds? No, I don't think any of us could. That's over hurricane force winds. Did you guys know that there's hurricane force winds blowing right now in our upper atmosphere? That's pretty cool. Yeah, you do. Anyway, guys, there's a lot of different areas on this website that you can click around. So go home and have fun with it. Science hand, thank you very much. That was really cool. It's science. Science is cool.
Spark Science.
All right, so the last thing I have for you today is my absolute favorite experiment that I've ever done. And guess what? It doesn't involve fire. You're welcome, guys. This is called the Cheshire Cat illusion, and it has to do with perception. So for this one, I'm gonna need some studio volunteers to come out. So let's have, yes, come on down, come on down. From Tennessee, come on down. Yes, and from Arkansas, come on down. Thank you very much. Tell us your names again. William. Riley. Alyssa. Anderson. Okay. So if you guys do this at home, all you need is someone else. So pair off, grab a buddy, if you would, and a mirror. Now, if you don't have a mirror, don't worry about it. It doesn't have to be exactly a mirror. It can be your cell phone, because what we're going to use is the reflective surface on your cell phone, okay? The size of the mirror also is irrelevant. It just needs to create a reflection. So, who are the teams? Team 1, raise your hand. Okay, William and Anderson. William, we're going to give that to you. Don't worry, everybody will get a chance. And Riley, we'll give that to you. So, people with the mirrors, I want you to come stand right here where I'm standing. Right there. Riley here. And Anderson, you're going to stand and face your partner right here. Alyssa, you're going to come and stand in front of Riley. You guys at home, when you do this, just have someone stand. Now, here's the important part of this experiment. The people who are standing right here, we want to make sure that whatever's behind them is not moving. So don't have them stand in front of a window with cars looking around, driving around, or anything. We don't want any movement back here, because that ruins this illusion. Now, what's going to happen is I'm going to go grab a mirror because I forgot to grab one. We're going to make Alyssa and Anderson's face disappear. Ha, don't worry, it doesn't hurt much. The way we're going to do it is by taking the mirror and putting it right here on your face. Okay, you guys know how to do that. Here, let me show you guys at home what it's going to look like. You're literally going to take the mirror, put it right there, and then you're going to tilt it to one side so you can see the reflection like that. So you can see my hand waving, and that's what we're going to look at. So as you guys do that, hold it, pinch the mirror at the bottom. Good. Now tilt the mirror toward one side and wave at yourself in the mirror. You'll notice that with your other eye, Riley, switch hands. you'll notice that with the eye that's not looking in the mirror, that image will vanish. Just like the Cheshire Cat in Alice in Wonderland. Whenever he was done, he would sit there and smile and wave and then slowly vanish. And that's exactly what's happening. Your brain only processes images that are moving. And in this case, it only pays attention to the stuff it sees reflected in the mirror and completely ignores the other stuff on the other eye. It makes it vanish. It's really cool. Did you guys get it to work?
Yeah.
Did you get it's weird. This also works with anything that you look at. It's science.
You know, that reminds me of the very first time I found my granddad hiding in the freezer. You ain't scaring me again!
Spark Science.
You know, science is really like a puzzle. I do this every week. You remember this one from last week? Couldn't figure it out. And science is like that too. Sometimes you have things that just are difficult and you just have to keep trying and trying and trying until you get it. Now it's your turn. Ready? Go! See you guys next week. Science hand. Yeah.